A very good morning, good afternoon, and good evening to everyone wherever you are. Ladies and gentlemen, welcome everyone to join the AIC 2021 workshop series with the title of Training on Data Analysis Using Gretl Software by Dr. Hamad Raza Zadi. This is a special session organizing under Connecting Asia in the 7th Asia International Conference 2021 for all our participants this year. I'm Dr. Yuli Nguyen from Vietnam, PhD in Education and Management. It's my pleasure to be a moderator of this session today. In my opinion, as a researcher, we need to enlarge the knowledge and skill in modern competitive business and education environment now. Researcher skills need to be updated regularly as the requirement and trust of researcher change and change in time. I strongly believe that the workshop today will bring the benefit to all when we can learn about the software for data analysis. Now, let me introduce the schedule today. I will start with the introduction of keynote speaker. Then after that, speaker will give a speech in 45 minutes. Then we move on the part of the question and answer. During the session, please mute your audio to avoid the interruption. However, we warmly welcome you introduce yourself or write a question in the chat box and we will respond to support you. Now, without further delay, I would like to introduce the keynote speaker today, Dr. Hamad Raza. He will deliver his speech with the title of Training on Data Analysis Using Gretl Software. Before start, let me brief some of his achievements. Dr. Hamad Raza holds PhD degree from University Technology Malaysia, UTM, and is Assistant Professor, Elizabeth Business School Government College, University in field of the accounting and finance. He has authored many research articles indexed in ISI and Scopus database. He is managing editor of Journal of Marketing in Information System, JMIS. He also reviewer of many reputable journals. Sustainability, for insight in the science, editorial, or economic applicator, Pakistan Journal of Multidisciplinary Research and Reader Insight Journal. Moreover, he is editorial member of Journal of Economics Info, JELI, and Journal of Management Info, JMI. He is also founding member of Connecting Asia and the APRA Research Network. He is expert in quantitative analysis and also professional trainer of Sparta as well as Gretl software. Now please join me. Welcome Dr. Hamad Raza. Dr. Hamad Raza, the floor is yours.
Thank you, Dr. Julie, for the brief introduction. Assalamu alaikum and good morning, good evening, and good afternoon around the globe. I am Dr. Hamad Raza. Already, Dr. Julie have given a brief introduction of me. So before further delay, I will start with my presentation for today's topic. I'm trying to share. Can the administrator allow me to share the screen? Okay. Thank you. Are you able to see my screen? Okay. The topic of today's workshop is data analysis using Gretl software. Data analysis, as you know, that in today's researchers network, one of the important factors that you need to publish your research work is data analysis. The data analysis part of your paper should be very strong. So we are using this time Gretl software. We are introducing a Gretl software which is freely available and a very easy and effective tool to analyze the data over time. Without, I will skip this slide as Dr. Judy has already told about my background. The basic outcome of today's workshop will be understanding of panel data. We will be working today doing practice on panel data. What are the type of panel data and what are the importance of panel data, and to know about different models that are used to in panel data to analyze the data, and what understanding of Gretl interface. I will try to explain the interface of the Gretl, and we will do some diagnostic test that is essential for performing model testing or data analysis before on the panel data. And then we will test different panel models that we have discussed using continuous variables, and then selection procedure of the appropriate panel model, which model is better and how. We will see this one, and then understanding and interpreting the results. These are the panel data. Panel data is a set of data that is one where there are repeated observation on the same unit across times. Means your company is you have one company and it has different data separated in number of years. The units may be individual forms, countries, or any set of entities that remain stable throughout the time. So the unit can be anything, the firm, the individual, or countries that remain throughout the time. Means your company remain throughout the time from year 2000 to 2005. This is how the panel data goes. The data related to the financial profitability of non-financial firms in Malaysia from 2018 to 2020 is an example. The financial data of the same firms were collected every year across 3 years. This is how panel data goes. There are different types of data set. Number one is time series data set, where entity X is fixed, but the time varies. Means the firm is fixed, but the time varies. This is called time series data. And cross-sectional data, where time is fixed, but the entities may vary. Means you are taking the data of only 1 year, but there are different firms in 1 year. And for the time series data, the firm is one, but the time is varying. Means you are taking data of 3 years or 4 years of that particular firm. But panel data is the combination of both time series and cross-sectional data, in which we take number of years. Time also varies, and also the firms are vary and also fixed. So it's a hybrid combination of time series data and cross-sectional data. So these are the there are two types of panel data. The first panel data is balanced panel data, in which we have the data of all the firms and in all years, which this is called as panel data. That is represented in this figure 1. The unbalanced panel data is we have number of firms, but some years data is missing. Like in 2018, firm A data is missing in unbalanced panel data, and also the firm C, the 2019 and 2020 data is missing in unbalanced panel data. So there are two types of panel data. Why panel data is important? Panel data can model both the common and individual behaviors of the group. Panel data contains more information, more variability, and more efficiency than pure time series or cross-sectional data. As I have already discussed, that it is a hybrid combination of both time series and cross-sectional data, so it is much better. It provides more information, more variability, and more efficiency. Panel data can detect and measure statistical effects that pure time series or cross-sectional data cannot. Panel data can minimize estimation biases that may arise from integrating groups into a single time series. Means panel data avoids estimation biases. As we have grouped many forms with different time series, so these are why most of the trends are going towards panel data analysis. Model of panel data analysis. That there are three common models of panel data analysis. Number one, we have pooled OLS model, which believes that there are no unique persistent among cross sections, means forms or countries, and no universal effect across times. So in pooled OLS, neither you have any, they consider that neither there is a unique cross section, mean form or country. There is no uniqueness in the form and country, and no universal effect across time. Whereas the second fit model, panel model, is fixed effect model. This pooled OLS model is the basis for panel data, and on the basis of pooled OLS model, we will decide which model is better. Either fixed effect model is better or random effect model is better. What is fixed effect model? Fixed effect model is the model that there are unique features of individual cross sections that do not change during time. These unique features are not correlated with the independent dependent variable of the cross sections. Means fixed effect means every form or every country has their unique features which do not change over time. So this is how fixed the assumption of fixed effect model. And the random effect model is the model in which it assumes that individual cross sections have random effect, random systematic effect. Before testing these panel models, we need to test our data, whether our data is have the normality, means our data is normal, the value range are in normal. So there are 4 diagnostic tests that are used to check the data. Number one is normality. Usually normality is tested by different tests, but we will practice in our Gretl software about Jobara test. That is one of the tests that checks the normality of the data that I will show you in the practical form. And the second diagnostic test is multi-collinearity. Means 2 variables in the data set have correlation or not. If they are, if the value of VIF test is more than 10, then it is assumed that the variables, 2 variables have the multi-collinearity, and the value less than 10 is considered as variables that can be tested together in a model. If the multi-collinearity exists between the data, we cannot perform further analysis, as the results will be not be correct. Heteroscedasticity means there is some variation in the data that need to be heteroscedasticity can be tested by white test, and I will explain in how we will perform white test in the Gretl software. And the fourth one is linearity, means all the variables have the same unit. So the measurement of the unit should be same for all variables. These are the 4 diagnostic tests that need to be performed before doing for to testing the models. Selection of appropriate model. In the panel model, there are 2 models that need to be selected. Either we need to apply fixed effect model or random effect model. The test that we use to select the appropriate model according to the data varies on the basis of Hausman specification test, which have 2 hypotheses. Null hypothesis states that if the test is not significant, then the random effect model is appropriate model. If the hypothesis Hausman test is significant, means its value, p-value is less than 5, then fixed effect model is appropriate. So we will see one of the sample data and see which model is better. Gretl software, as you know that we are talking about today's Gretl software. So I want to introduce some key features why Gretl software is important and why we need to learn this software. Gretl software is a free software and an open source software. It is easy, intuitive interface, means it has no command prompt. It is graphical representation of the things, and you can easily perform the analysis in that software. And graphical user-friendly software already discussed, and wide variety of estimators, means you can test both panel data and time series data in this software. And output models are you can have three types of output model. It can be in latex file, in tabular form, or in equation format. So this software can be downloaded from this source website. So Gretl software is one of the tool that financial researchers and autonomous metrics researchers use in their analysis. So let's begin without waiting any time, and let's begin with our hands-on session, which is the core of this session, this workshop. Before going to Gretl software, I need to show my Excel sheet, which I created one sample data set for today's practice workshop. Okay, in this worksheet, Excel sheet, I have created the panel data as explained in the website, in my presentation, that these first column represents the firms, means cross sections, and the second column represents the years, different years of data we have created. Like we have taken from 1993 to 2010 data for each of the cross sections, means each of the company firm. And there are four variables. The SP variable is the dependent variable, and whereas EPS size and DPR is the dependent variables. So I have taken share price of the firms and earning per share, firm size, and dividend per share as independent variable for our today's workshop practical testing. So these two are the cross sections which is needed for the panel data, as we have the same firm existing in 18 years, over 18 years of data, and we have around more than what we called more than 1,117 observations. So total number of observations we have is 1,170. So now we will click on this Gretl software. The Gretl software is look like this one. We will click on this software. And this is the starting interface of the Gretl software. As I have already told you that it is not a command prompt. It is basically a graphical user interface. So there are different toolbars. Number one is file. You can open your data from the existing file. Like I have created the data in Excel sheet, so we will use open data, and you can create the data in this Gretl software as well. And these are the different databases that can be used for data. So the second one is tools. So these are the different tools or that are used in our data. But we are more related towards, as we are, our workshop is today's more related towards the basic analysis of panel data. Like we will discuss the diagnostic test, and we will test the OLS and which model is better, either fixed effect or random effect. So we'll practice that one. So first of all, we will start our worksheet to upload in the data. So we will select user file. User file means I have created the file. My file is on that desktop, so I will select the place desktop, and I will select from here, as my file is in Excel file. So I will select Excel file. You can save your files in different format, but we will select the file. So this is the file I have selected. So click open. It is asking that column 1 and row 1. Just click OK. So he said that one sheet is found and 6 variables and 1,116 observations is found. Remember, I told you that there are total 1,117 rows in the sheet. The first row represents the variable, that is 6 variables. We have, like you can see, we have 6 variable over there, like 1, 2, 3, 4, 5, 6. And the first row is exempted as its variable. So altogether, the remaining is 1,116 observations. So press close. Now the data is asking whether you want to import the data that we have imported has been interpreted as undata set. Means if you don't classify this data, then it will be treated as cross-sectional data by standard. Do you want to give the data a time series or panel data? If we are doing panels, the time series or panel data, then we need to press yes. So here are three types of data structure that I have discussed in my presentation, but today's we are using panel data. So this sheet is based on panel data. So we'll select panel and click forward. You can use any of the options, but more appropriate option for our understanding is use index variables, the variables that we have set in our data sheet for the cross section and the time. So click forward. Then you can see that unit or group index variable is forms, means the form is the variable cross sections and the time index variable is years. So they have already picked our forms as a unit and time years as time series variable. So we will click forward. So the panel data states that there are 64 cross sections, means in this data sheet we have 64 companies of data that varies over 18 years, starting from 1993 to 2010. So altogether 18 years data. Then we apply. So that now you can see that our data sheet is uploaded on the system, and our there are 6 variables like firm, year, share price, EPS, size, and dividend per share. So we'll start our analysis by seeing the summary statistics of each variable. Like we want to see the first of all the first analysis, the basic analysis of any variable is that we see the descriptive statistic analysis. So descriptive analysis can be seen in view column. There is summary statistics. We select on summary statistics and we select the variable, like we selected share price. So we'll put it here and we'll press OK. The software is asking about whether we want main statistics or full statistics. So we want main statistics that are based on mean, maximum, minimum number, and standard deviation and missing observations. So it has given us in a single click, it has given us the summary statistics of this variable. You can also I practice again. You can also have multiple variables summary statistics at one time. If we select all variables and we click here, so we press OK. So it will give in a tabular form all the variable summary statistics at a time. So again, in the view, the second analysis we usually perform in our papers or in our thesis is mostly related to correlation matrix. What are the relationship between two variables? So we will select our all variables. The SP is right dependent variable and other are independent variable. We'll click on next and we will click OK. And it will create what you call a matrix based on, this is our SP. SP means share price. Share price with the share price has a one-to-one relationship, and the other one has a positive relationship. Remember that in correlation matrix, the value of each variable, independent variable with the share price dependent variables, should be less than 70% as indicated by the researchers. Otherwise, it seems that there is some linearity or issues exist in the software. Means two variables are linear and cannot be tested together. So we need to adopt other procedures in that. But in our metrics, we can see that our values are less than 0.70. So our variables are have no collinearity among them. Then we will go to there are the other options, like you want to take the log of the selected variable. You can easily just click on the log and the log variable will be created. Means log means you need to convert the data that you have data in other format and you need to convert it into ratios. So we'll take the log of that variable. So these are the different techniques, or you need to take the square root of any selected variable. It depends on your analysis, what you want to do. So it is available on single click. You can easily do this kind of analysis and play with the data. Today analysis we are running is more towards the model, how a weekend paper can be generated by data set in which we need to have descriptive statistics, we need to have correlation matrix, and we need to have the model that through which these variables are tested. So this workshop is more towards the summary statistics, means descriptive statistics, and correlation matrix means the matrix that we need to test the correlation between the variables, and the model we are discussing three types of. This is old ordinary least square model, means old OLS model. So the first model, as we discussed in our slide, that we are testing ordinary least square model. So we'll click on ordinary least square model. As discussed, that share price is our dependent variable. So the software has asked in for which one is that dependent variable. So dependent variable will move share price, and the other variables, like three variables, are the independent variables. So we will, in the redresser, we need to redress these variables against dependent variable. So we'll click on redresser and we'll click OK. So here you can find that the regression pooled OLS is run, and the model indicates that you have these cross sections, and the relationship of each variable with the coefficient value and the significance level p value can be found. If the value is less than 5%, it means that it has a relationship with the dependent variable. Like and the coefficients tell us the direction of the value, like which variable has a positive impact or negative impact. As you can see that EPS size and dividend per share all have a positive sign in this coefficient, and the significance level is also 3 stars indicate that this variable is significant at less than 1%, and is less than 1%, and 2 stars indicates that this variable is significant at less than 5%. And the important thing we need to see is F model, and also the R square of the model, and the p value. Means p value shows that this value is less than 5%. This means that this model is significant, and this model is a good model for our test. So remember, I told you that we will perform different tests, diagnostic tests. So in Gretl software, first we run the pooled OLS model, and then on the basis of pooled OLS model, we test our data. So here is the data in the pop-up window where we get the pooled OLS regression. There is the option of the test. So we click on the test. There is heterostochasticity test. We can see white test. So just click on the white test, and it will provide us this table. And we are more concerned about p-value. P-value means white test represents that whether it has a heterostochasticity or not. As you see that the value is significant, its p-value is less than 5%. So it means that null hypothesis is rejected, that there is no heterostochasticity in the data. This means that this states that our data consists of heterostochasticity. And as I discussed that heterostochasticity in the panel data is heterostochasticity, if it exists in the data, then it is very difficult. It is not. It does not give us appropriate results. But there are some what you call relaxation in the panel data. That's why we use panel data. That panel data does not consider heterostochasticity. According to the author in 19 paper, if I'm not wrong, it's a paper in 1980 white test, which states that if the number of observation is more than 100 observations, then heterostochasticity in panel data does not matter enough. So you can perform the analysis on that data. So as I have already told you that my data is more than 116 observation, 1,116. So in this large amount of data, the heterostochasticity does not matter enough. The second test is normality of the residuals, means whether our data is normal or not. So it can be represented in Gretl by 2. As you can see that this should be like this. So almost we have normality of the data moving with our curve, but there are some values that are a bit outside or outliers in the data. But overall, our data is normal, so we can have a normality test, and which p-value is also 0.6%, which is not significant, which means that almost our data is normal. So there is no issue in our normality of data. And the third test is related to what you told the third test is related to VIF. VIF means we reflect on panel diagnostic test, and here we can get the outcomes of two models, that is multicollinearity and also the which model is appropriate, means either fixed effect model is appropriate or random effect model is appropriate. So we will use panel diagnostic selection, and here you can see that it has calculated the VIF. It has calculated the fixed effect model estimators, which represents that size and dividend per share is have a significant relationship with share price. And here is the random effect model, which also states that size and dividend per share has a, but their estimation is all have some values different. Like in size has 0.55, whereas in random it has 0.49. So it varies. This is the Hausman test, which we need to see to decide which model is better. As I already told that if the p-value is less than 5%, then fixed effect model is appropriate, means our null hypothesis that random effect model is appropriate is rejected. And our alternative model, alternative hypothesis H1 is accepted, that fixed effect model is appropriate. So you need to see the p-value. This is the p-value this one. So p-value is 0.96 e to power 12, means 0.000096. So our value is less than, p-value is less than 5%. So we state that the fixed effect model for our data, the fixed effect model is more favorable and appropriate in terms of random effect model. So null hypothesis will be rejected. So here is the in the analysis, like in OLS, in the analysis, you can test the diagnostic test collinearity over here. So you just click on the collinearity and it will give us the VIF value, means variance inflation factor. As I have told that if 10 values more than 10, this indicates the collinearity problem. And if there is collinearity problem in the data, the results will not be appropriate. As you can see that each variable, independent variable, collinearity is tested among independent variables. As independent variables, EPS size and dividend per share all has value less than 10. So we can say that these variables don't have collinearity with each other, and it can be tested in one model. So as we have already discussed that in panel diagnostic, sorry, my Gretl was closed, so I need to get it again. As software was shut down due to some error, so I'm uploading the sheet again. You can see this is, you need to click yes, and then panel, forward, use index, variables, for many years is already selected, forward, apply. So these variables are already created. So we already see that model is a pooled OLS model, which states that the share price and all dependent variables is okay. So this is how you run the model. If, for example, the we have tested the diagnostic test and there exists a what you call heteroscedasticity in the data. So you need to rule out that heteroscedasticity. So one of the methods suggested by White test is you need to reboost the standard errors. You need to reboost the standard errors. So how we do reboost the standard errors in pooled OLS? We will select dependent variable and we will set independent variables here, which is already, and just click on this one, this reboost standard error. They will already selected, and then press OK. Now our results are more reboosted. Like in our previous one, these all have less than 1% significant sign. But when we reboosted the data, we try to rule out the heteroscedasticity in the data. So which gave us appropriate results that EPS is has significant at 5%, and size and dividend prices represent is significant at 1%. So same if we test the diagnostic test, so we will decide whether, sorry, we'll decide the Hassman test have no effect on this one. It will be the same results. So fit as the value is less than 5%, so fixed effect model is appropriate. So we'll go on model and we will go on panel, as we have decided either fixed effect is or random effect model. So we'll select again our dependent variable and also the independent variables. And as I have already told that there is a heteroscedasticity issue in our data, so we need to resolve that, rule out that issue. So we'll click our reboost test here, and then in the fixed effect model, the reboost test is not there is no issue of running the heteroscedasticity data. So we will not select reboost standard errors. We will select the appropriate fixed effect model, and then we will click on OK. So this fixed effect model, you will get the result like this is more appropriate results, as we state that for panel data, the two model they was more appropriate, either random effect model or the fits effect model. So we applied fits effect model based on our Haussmann test. So it gives that EPS has a insignificant relationship with the share price, whereas firm size and dividend per share has a significant relationship. And this its F test is 41 and its p-value is less than 5%, which represents that our this model is significant overall. So if, for example, your data rejects the Haussmann test, so you can run in the same way, for example, in the same way, the random effect model, you can select here and you can just click on OK, and it will give you, it can give you the output of the random effect. This is all for my today's workshop, and the next we can explain it later on in our next session. Hello.
Thank you very much, Dr. Hamad, for amazing presentation today. I can see how the Gretl software can support for the researcher in the quantitative data analysis. I remember that we have the SPSS before. We very happy already, and after that we move on to the ARMOS, and after that Smart POS, and yesterday we learned from SPAPA, and today Gretl software. I really high appreciate Connecting Asia own way to provide the new software to support for researcher. So now we move on to the question and answer session. I hope that participants today will give the question to ask Dr. Hamad, and Dr. Hamad will help you to understand more related to the digital software. So any questions? Can we have a deep information session? Yes, you can email directly Connecting Asia or Dr. Hamad. He will share with you. So,
I need to share my email address if somebody wants help regarding the data, so they can just email me at my email address, and I will help out them to do analysis or any support or consultation regarding the digital software. Just I have mentioned this my email address, so they can email them.
Thank you, Dr. Hamad. I totally agree with you. Yes, in the software we cannot learn in 1 hour. In here, you just show in the overview, but when especially student and young researcher, they do the real research. They need to do data collection very carefully, and after that, step by step. I hope that with the email from Dr. Hamad, all the students or young scholar can contact directly to Dr. Hamad to support in the mentor or as a supervisor, or maybe give the lecturer for students. Yeah. So in here, we have one question here, Dr. Hamad. What is the limitation of this software?
The limitation of this software is mostly this software is more towards financial observations or results. Means this software is mostly developed for financial analysis, like for financial data and econometrics data. So the main basic or the purpose of developing this software is more towards financial and econometrics data. For example, if you have data from other fields like management, from marketing or some observational data, so you need to have another software, like you have already discussed in your presentation, in your talk, that we have learned many software like AMOS, SPSS, like this. So this is one of the limitation of this software, that only financial or econometric data can be tested in this software.
Okay, thank you, Dr. Hamad. So is it okay with the Ahmed? If anything question, just ask later. Now we move to another question. Dr. Ahmed, if there is a heteroscedasticity problem, does Gretl has a solution for it?
Yeah, as I discussed in my presentation, that the heteroscedasticity mostly exists in the panel data, as we have different set of companies, and also these companies that are varying from are over in different number of years. Like we have the data in 18 years, so it is not possible that every company, like we have 64 companies, have the same type of data or same type of financial ratios which the other companies have over the number of years. So mostly in panel data, heteroscedasticity exists in the data. The solution for heteroscedasticity is already given by White 1980 paper. That White is as we have done the heteroscedasticity test using White test. So the same paper, 1980 White test paper, tell us that if there is the panel data and the number of observations are more than 100 observations, so this sometimes there may be the distance of heteroscedasticity, and it can be resolved by clicking on the reboot standard errors. If you simply check on reboot standard errors, so you can resolve the heteroscedasticity of the data, and the software will do.
Yes, is okay, Dr. Zaitun. Any questions?
Thank you.
Thank you, Dr. Zaitun, for great questions. Any else have any questions related to the Gretl software? You can raise a hand or can write in the chat box and we will respond it. When we waiting another questions, Dr. Hamas, I have a question like this because in our field in social science and education, so we usually apply the smart BOS to test the same. So can you, if we can apply the Gretl software to test the same model?
Actually, you can use this model for your social sciences, but the software this is actually a software that is developed by programmers C language programming. So it is more the method, the model developed in this software is more towards financial and econometrics data. So that's why this is one of the limitation of this software, that this is more, it will handle more betterly the financial or econometrics data. Yeah, you can test your data in this software, but the results will not be as efficient as tested in the AMOS or Smart PLS software if you test the data, the same data over there.
Yeah, because when have a more software and we also very interesting like this, but when the very big number, big number size, and we apply the smart BOS and test model very effectively, and smart BOS also have the red color and the green color to have the student, to have the researcher easier to recognize that is the good data or that we need to support or we need to reject it. So can you you talk about the Gretl software, very advanced for the finance and accounting. I think that is very important and necessary for finance and business students to learn this software, right?
Yeah.
Okay. So any question more? Any question? Anyone want to ask anything? Oh, Dr. Ahmed also have a question here. Dr. Hamad, so there is no specific method. So heteroscedasticity. Okay, sorry.
Yeah, the specific method, if you talk about the specific method, the problem is then you need to reduce your number of companies. If you reduce the number of companies and number of years, then your data will automatically be in a balanced form and have a less heteroscedasticity. But if you are testing the same number of companies over the same number of years, so there may be a chance that heterotoxicity exists. So there are guidelines for this diagnostic test, but there is no appropriate method. Every researcher adopts its method according to the literature. So one of the literature, as I already discussed, that White 1980 says that if there is more than 100 observations, so there is always a chance that the heterotoxicity exists in the data. So when there is a heterotoxicity, you need to reboost the standard errors. If you want to remove the heterotoxicity in the data, so your number of observations should be less than 100.
So it's okay, Dr. Ahmed Grosso. Yeah, thanks a lot. He will like this. So any questions else? Yes, so clear for you. Thank you, Dr. Hamad. So any questions? I think no questions, right?
In the meanwhile, we can have one photo, a group photo.
Yes, so kindly turn on the camera. We have the group photo with Dr. Hamad. Then after that, we move to the closing session today. Hello, everyone. Kindly turn on camera and give smile. We have the group photo today. So, Dr. Norman, kindly to help us to have the group photo. Yeah.
Yes, doctor, I'm doing.
Kindly turn on camera, participants, if you can, yes. Ah, Lily, thank you from Indonesia. Come here with us, yes. Dr. Norman, can you say 1, 2, 3 for people smile, please? Turn on camera, friends. Done, Dr. Norman?
Yes, done. Thank you very much.
Okay, so now we move on to the closing session. So now 1 hour was very fast, and we have a very amazing presentation from Dr. Hamad today. Again, I would like to thank our Dean Director Connecting Asia, Dr. Imran Khoury, Connecting Asia team for organizing successful workshop series of the expert sharing session today. Thank you very much to keynote speaker Dr. Hamad Raza for excellent speech with the informative and enriched experience today. Thanks to all support team, technical team, Connecting Asia member, all participants today for your cooperation, full support throughout, and congratulations to everyone and audience for making this program a success. 10. Digital technology advance have opened the new door to connect us global to understand together, sharing experience and develop together better with the support of organizing by Connecting Asia. I wish you all enjoy the program today and apply the knowledge and experience today to your own goal and career development. Thank you and see you in the next collaboration program. And now also Christmas coming and Happy New Year. Let me say Merry Christmas and Happy New Year to all. Thank you and bye-bye. See you later.
Thank you all for joining, and thank you Connecting Asia